Okay, so I'm going to pick up with 12 to 16, and then this is going to be the end of questions from Unit 1. Okay, let me remember to start my timer this time, just in case. Okay, so in number 12, it says, for each function below, find the formula for f of -1 of x, which is just kind of a fancy expression for inverse. It's just sort of a fancy way of saying an inverse. And we have to state any restrictions on the domain of the inverse. Okay, the whole thing with inverse is that x and y swap. Okay, so anything from the original equation that was x is going to be a y in your new equation. So they're literally going to swap. So if I take, for a, for example, if I take a look and think about what my domain and range might be, it's going to be the complete opposite for my inverse function. Okay, so let's start with a, and let's think about what my domain and range might be. Right? Before I even do any of the solving for the inverse or anything like that, let's kind of start with what we have here. Okay, what I notice is that this is a square root function. And what I know about square root functions is that you can't take the square root of anything underneath 0, right? Like it has to be 0 or greater, right? So anything under here has to be something that's bigger than or equal to 0. Okay, so if I take a look at this one, and what I have underneath here is x plus 2. I know that has to be greater than or equal to 0 when I plug in an x. So if I subtract that 2 over, I know that I can put in anything I want as long as the x is greater than or equal to -2. Right? Or you can think of it as, you can also write it as -2 to infinity. You can write it that way too if you prefer. Let me move the range down. Okay, so what about the range, right? What outputs are we going to get? Well, I know what a square root function looks like, and I'll kind of sketch it up here. It kind of goes off like this. So it has a lot of restrictions to domain and range. And then this one, because it says plus 2 on the inside, that's affecting x, that means it's going to shift it to the left too and sort of go on like that. So I didn't move it up and down at all, which would be a concern if I was doing something for range. But because I didn't move it up and down at all, it looks like it's going to be greater than 0. So we can say that it's going to be from 0 to infinity, or you could say the y's are greater than or equal to 0. You could say it either way. Okay, the reason I did that is because it says that I have to state any restrictions on the domain of the inverse. And my domain of my inverse is going to be my range of my original. So, because they're going to swap, the domain and range, the x and y, everything's going to swap. So since this one had a range of from 0 to infinity, that's going to be the domain of my inverse. Okay, but I need to go find that new equation. All right, so I'm going to swap colors here. First thing I'm going to do is rewrite this, just kind of using y. And step 1 is going to be to swap the positioning of the x and y. So I'm going to rewrite it as x equals the square root of y plus 2. So I want to solve it for y. So in order to get rid of the square root, we're going to square both sides. And that frees up the y and the 2. I can't remove the 2 until think of the square root symbol as like a trap. It's like keeping it in there. You can't get rid of it until that's gone, and then you can move things around freely. And now I can subtract the 2 over, and I get x squared minus 2 equals y. Or the inverse of the function is x squared minus 2. So here is the inverse, and the domain is going to be the old range. So it's going to be 0 to infinity. Okay, so let's think about this one. This one is a cubic function, and just kind of a quick sketch of the parent graph. A cubic function looks like this. And it looks like, what are we doing to it? It looks like we're moving it up 4. So this graph is going to look something more like Like this 0, 0 point is now going to be like right here. So it's just going to look something like that. It's going to be shifted horizontally up 4. Okay. This kind of function doesn't have any restrictions on domain and range. You can see if you kind of scan the graph left to right, you know, it's going to go back and forth forever. It's steep, but it's going to keep getting wider and wider, and up and down. It goes both directions. So my domain and my range are going to be the same, of negative infinity to positive infinity. So no matter what I get for my equation for my inverse, I know that I'm going to get negative infinity to positive infinity. All right, so let's do the same process. I'm going to write it with y first. And then I'm going to swap the position of my x and y. Okay, in the last example, I had to get rid of the square root symbol first because it was kind of trapping the y and the 2. Whereas in this one, this cubic, we're going to wait to the end. We're just going to get rid of the 4 first because it's free to move around. It's not trapped by a cubic or anything like that. And so actually in this problem, it's going to be the last thing we do. The opposite of cubing is taking a cube root. So I end up with the cube root of x minus 4. So I'm just going to write it in function notation. Inverse is the cube root of x minus 4. There it is. And my domain is negative infinity to positive infinity. Okay. 13, true or false? Okay, the function g of x, 5 times the function minus 2, represents a vertical stretch of the function by a factor of 5, followed by a vertical translation down 2. So no matter what the function is, you can see that they're just giving you f of x. They're not even kind of telling you any specific kind of function or anything like that. Really what this question is about is, do you know what the 5 does in that position, and do you know what a minus 2 does in that position? Okay, the 5, this a value, usually the number in front, we call it an a. No matter what the function is, we usually call it an a value. This is going to be like your multiplier of y. We call this our vertical stretch. Right? This is going to affect my y coordinates for sure. And then after the function, there's a minus 2, and this is also going to affect y, but it's going to be a horizontal translation and it's going to follow the rules here of minus 2 or down 2. So let's see what it says. It says a vertical stretch of a factor of 5, that looks correct, followed by a vertical translation of down 2, and that also looks correct. So this one is going to be true. Okay, in the second one, in B, this one, the 1/2, is going to end up being a vertical shrink, right? It's less than 1, so it's going to, affect the y by shrinking the numbers instead. Now, the other number in the problem is the x over 4, which you can think of that as being written as like 1/4 x. That's the same thing, so if it's easier for you to visualize it that way. Remember, anything that happens to x is backwards, right? Anything that happens to x is going to be the opposite of what you think. So this is multiplying, right? This is a multiplier of x. So it's not one of the ones that's sliding it side to side. We know that always goes opposite of the sign. But this one, we're going to call it a horizontal. And this is actually going to be a stretch, because it looks like a shrink, but it actually means it's a stretch by a factor of 4. Instead of 1/4, it's like the reciprocal. It's going to be the opposite. So let's take a look at what it says. It says a vertical and horizontal shrinking, and that's actually false, because the horizontal is a stretch, not a shrink. So remember, everything that happens to x is backwards. Okay, so number 14, looks like we're going to be matching. Okay, so on this one, this is going to be a y, a change of y, which is vertical. Right? That's going to give me a vertical stretch. Okay, This one, notice it's on the inside. This is going to give me a horizontal. And hopefully you're saying to yourself, shrink, right? Remember, it's backwards. Anything in there is backwards. So this next guy is going to give me a horizontal stretch, right? It's going to be times 3. And then this one, vertical, this is going to be my shrink. So everything that happens to x is opposite. Everything that happens to y, is exactly how it should be. So let's see. For the first one, vertical stretch, this one should be B, and then C, and then A, and then D, if we kind of match those up correctly. Okay, so watch out for those two in the middle. Those are probably the two tricky ones. Okay, 15 and 16. Which of the following? Okay, so it's a multiple choice, and I just kind of have to figure out from this function right here, how did I get to this function right here? And I can see that, they generally have the same shape, but definitely some of the ordered pairs, it looks like it's like steeper or something. Let's try this by figuring out a couple of these ordered pairs. Like, this is the ordered pair 2, 0. This is a pretty good order pair, 0, 1. And then 1, 2, 3, 4, 1, 2, 3. This one's negative 4, 3. So we've got these like 3 ordered pairs here. And one strategy, there's lots of strategies, but one strategy is we could kind of test the rules down here and sort of see if they work. Like this 2 here, this is going to be multiplying y. And this x would add 3 to x. So we can kind of take the ordered pair negative 4, 3, and basically see if that works. I'm going to multiply the y by 2, and that would give me a 6. And then the x coordinate, I'm going to add 3. So this would give me negative 1, 6. So if this was the rule, this ordered pair right here should now be at negative 1, 6. Ooh, and actually it is. Let's try it on the 2, 0. Let's see if it works, because maybe we just got lucky. All right, the y should be times 2, so that's going to stay a 0. And then it says x minus 3. That means we're going to add 3, so that means this new one should be 5, 0. 1, 2, 3, 4. Ah, I think we found it. Right, we got pretty lucky on this one. The answer is A. Okay, and then what we're going to do, the last one, is we're going to sketch the graph of that last function. So I'm going to give myself a decent scale here. Okay, it looks like we're taking that last graph, and these symbols mean absolute value, right? Which means it has to be like greater than 0. So anything that was negative, we're going to force it to become positive. So let me go back for a second. This was the f of x, this one right here. And the whole entire graph is above 0, except for this little section right here, right? Like from, let's see, let's find this point. 1, 2, 3, 4, 5, 6. So at negative 6, 0, it's above, 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 above. This is the only section that needs to be edited, because that's the part that we're going to force it to be positive. So our final graph is going to look something like that. We're just going to flip that part up over the y-axis, or I'm sorry, the x-axis. We're just going to flip it up. So my key points are negative 6, 0, negative 4, 3. Okay. Negative 4, 3. I think 2, 0 was 1. So like this is the part that we weren't changing or anything. I think it looks something like that. And then the part that was down here is the part that we are going to, that's probably a little too steep, is going to end up switching up like that. And that is the sections from Unit 1. See you later.